Hi, welcome to day 2 of .NET Conf 2017. My name is Maria Nagaga, and I'm here with Mete Atamel from Google. He's going to be talking to us about containerized applications and ASP.NET Core. We will be taking questions throughout the talk, but we'll be saving them for the end. So take it away, Mete.
Thanks for the introduction. Hello, everyone. My name is Mete Atamel. I'm from Google, and I'm based in London. So today I'm going to be talking about containerized ASP.NET Core apps with Kubernetes. Before I start my talk, I'll turn off my video to save some bandwidth, and then we'll get started. All right. So before I start talking about Kubernetes, I want to provide some background on why we even need containers and why we even need things like container management systems like Kubernetes. Because I think it's important to understand where these things are coming from and what they actually provide to us. So let's just go through that first, and then after that, I will be talking about the basics of Kubernetes. I'll be showing some demos, and then we'll just wrap it up after that with some questions. All right, so some of you might recognize these, the floppy disks. I actually started my programming hobby, I should say, with the one in the middle, the 5-inch one, actually. And I remember back in the day, this was when I was like 12 years old probably, I had an MS-DOS disk. I would put that in my computer, turn it on, that will load my operating system, and then after like a few minutes, I would get the A prompt, and then I'll take the disk out and then put my other disk, which was, I think it was a black disk. It was either GW basic or Q basic. I don't remember which one. But then once in there, I would just get into basic programming language, and then that was it. Like I would be in there, I would just write my code, and that's it. So all I had at the time was just this one disk to load the operating system, another disk to load the development environment. And then I also had a book where I was copying code. So that was kind of my Stack Overflow of the day. And that was a lot of fun. Because I would just look at what the book provided, and then I would just try to copy that. And then at some point, I wanted to try something different. There was no internet, there was no Stack Overflow, so I would just try to figure it out myself, and I would be lost in like programming. And I like those days because everything was so simple. Like all I had to worry about was my book, my actual program, and just trying to figure things out on my own. But since then, a lot of things happened. Obviously, the biggest thing in my mind is the internet. And after the internet, we had a lot of new things and technologies that came into being. So we had like firewalls and version control and virtual machines and cloud computing and machine learning and IoT and big data. So there's a lot today, and it's impossible to know all of this in detail. So what I try to do is, I try to learn the landscape of all these things, but at the same time, I'm trying to pick bits and pieces of it that I'm interested in and learn them in more depth. So that's all I can do nowadays. So when you want to solve a problem today, you still start with the code. So let's just imagine that this red box is my code. It doesn't live on the disk anymore. Usually you write the code and you either host it, depending on the type of the code, either on a mobile phone or you host it on a server somewhere. But at the end of the day, this code lives on some kind of a machine, right? And then someone says, well, what if this machine goes down? What do you do? So to avoid that, what you usually do is you replicate the same code on multiple machines. So this way, if one of the machines goes down, you don't have to worry about it. The other machines are still running. But now you have a problem. How do clients get to your machines? So what you usually do is you create a load balancer that has a stable IP. And then from there, the clients can go to the load balancer. And then from the load balancer, you can get to the machines. So that works. That's great. But then how do you even know if the machines are healthy, right? Because they can go down. So what you usually do is you create what's called health endpoints. So the job of these endpoints is to check your app and your machine and make sure that everything is working. And if everything is working, they will report as, I'm healthy. Otherwise, they will report unhealthy. So that's great, but then someone actually has to check this health endpoint. So it's either the load balancer that will check this endpoint, or you usually have something like a health checker that will ping these health endpoints and then figure out whether the instances are healthy or not. And then if the instance is not healthy, it will probably take some kind of action. So it will probably tear down the instance and create a new one if it can. So this is all great, but then everything is living in a single zone. Maybe you're using a cloud provider or something, and then it's living in a single zone. And sometimes the whole zones go down. So if you have a business critical application, you don't want everything to live in a single zone. So what you do is you create the whole setup with the code and machines and endpoints and health checkers and load balancer in a different zone, just in case something goes wrong with the first zone, right? Okay, this is a lot of work, but still it works. But now you have another problem. How do you keep these zones in sync, right? Because every zone has a state, so they need to be replicated to the other zone. So what you usually do is you create something like a task queue or some kind of queue in the middle where the state from one zone to another zone gets replicated through this queue. This way the two states are in sync. So this is great. So we have our zones, they're in sync with the state and all that kind of stuff. And if your app is successful, at some point you want to scale out. You want to add more machines. So you can do this manually if you want, but usually you want some kind of elastic scaling. So you want to scale up and then scale down when you don't have that much load. So what you actually end up doing is you either use or create your own autoscaler that looks at some of the metrics or your app and figures out whether it needs to scale out or scale down. So this autoscaler will basically give us the elasticity that we need in our applications. So if you look at all the things that we have, we started with the code, and that's what I care about because that's what is solving the problem that I want to solve. But in order to make sure that this code is running in a scalable, resilient, and redundant way, I have to create all this other stuff, right? And these things, they're needed. They're not optional anymore. Yeah, because we want our services to be scalable. We want them to be resilient. So they're not optional anymore. But I don't necessarily want to care about this because I'm an application developer. I want to solve real life problems. Having all the other things is taking the time away from me and from the problems that I want to solve. But that's the reality that we live today, right? So if I want to imagine how the software development should be today, I think there are three key things that I want to make sure that it's true. The first thing is I want to be able to write code in any language, and I want to be able to run that code any way I want, exactly the same way. I think this is crucial. We shouldn't spend our time trying to figure out if this code is going to run the same way on this kind of operating system or that kind of operating system. We should be beyond that. The second thing is I want my app to be optimally deployed and managed. And I don't necessarily want to do that myself. I think we should be beyond the times where everyone has to be a sysadmin, right? We should be able to write our code, define our health endpoints, and let someone deploy it in an optimal way in the infrastructure that we have and manage it for us. And the last thing is that I want all the resources that I need for my application to be provisioned on demand as I need them. If I need them, they should be there. If I don't need them, they should go away, and I should pay for what I use, right? So I think if we have these three pillars, we will be in a good shape. And the good news is that I think we're getting there. So if you look at writing your code in any language and running it anywhere exactly the same way, well, that's what containers are trying to do. So Docker or Rocket, these are the containers systems, and that they're all trying to make this a reality, basically. They're trying to create an environment where you write your code and it runs exactly the same way. When we look at your app is optimally deployed and managed, well, that's what orchestrators are all about. So Kubernetes, Docker Swarm, Mesos, they're all trying to take your containers and deploy them in an optimal way and manage them as much as they can. And finally, all resources being provisioned on demand, that's what the cloud is all about, right? So Google Cloud, AWS, Azure, they're all about resources and infrastructure being on demand. So I think we are heading in the right direction, and these things are coming together. So maybe there's hope that I will be able to focus on my code and not worry so much about the infrastructure running my code going forward. So now, first, let's talk about containers and why we should care about containers. And then we'll get into some sample app and take that app and then containerize it and take a look at that afterwards. So in terms of why containers, if you look at how we used to deploy applications, it kind of looked like this. We had a physical machine And then on top of that machine, we would install an operating system, so the kernel. And then on top of the operating system, we would install some libraries that our applications need. And then we would deploy our applications on top of the libraries. So the good thing about this model was that it was really simple. So you have a single machine, single operating system, single set of libraries. But the bad thing is that these apps are totally dependent on each other. Like if you change anything about the operating system, or if you change anything about the libraries itself, you could potentially break any of these applications. So there's no isolation whatsoever. Then came virtual machines. So the idea of virtual machines is that on a single machine, you install multiple virtualized operating systems. And in these virtual machines, you have the operating system, the libraries, and the app itself. The great thing about this is that everything is totally isolated. So you're not going to break apps because you change the kernel, because you only change the kernel of the virtual machine itself. But the bad thing is that instead of dealing with single machine and single operating system and single set of libraries, now you're dealing with multiple operating systems and multiple libraries, and these virtual machines, they're heavyweight. They're not small, so it's hard to create them. It's hard to move them around. So even though they provide isolation, they're not so easy to use. And in terms of containers, basically containers, they try to combine the best of both worlds. So in containers, you have a single machine and a single operating system, but you're virtualizing from libraries up. So the app and the dependencies of the app, the libraries, are virtualized in what's called containers. So the great thing about this is that your apps and its dependencies, it's isolated from each other, but at the same time, you don't have to deal with multiple operating systems, right? And these containers, they're much more lightweight compared to virtual machines. So they're very easy to start. They're very, very, very small, so they're easy to move around, things like that. So what is a container? As I mentioned, it's just a lightweight way of virtualizing your applications. They started in the Linux world, so they are Linux processes. But recently, we also started having Windows containers as well, so you can have Windows-based containers as well. So they're lightweight, they're sealed and isolated, and they're very easy to deploy. They're very easy to introspect, so you can actually get into container and look what's happening. But for me, the most important part is that they're composable. What that means is that you can have your app that depends on a base image. So that's kind of like the base dependency that you have. But then someone else can take your image and layer their dependencies on top of that. So this way, you're basically layering your dependencies on top of each other. So it's very easy to layer things on top of each other. And the other good thing is that all these layers are cached. So if your base image is being used by multiple containers, it will be cached, so you don't have to download it all the time. So Docker is the main container platform, but there are others like Rocket from CoreOS as well, and I'm sure there will be more going forward. So in terms of Docker, basically Docker made the concepts of containers available to everyday developers. So they basically made containers popular, and they provided the tooling around containers. So the idea with Docker is that you create a Docker file. In this Docker file, you define your dependencies, you define your environment, and you define what happens when your container starts. And then from this Docker file, Docker creates what's called a container and makes sure that this container runs exactly the same way, no matter where you're running it. So Docker provides all the infrastructure needed to make sure that this container is running exactly the way you describe in the Docker file. All right, so now what I want to do is I want to first build a really simple ASP.NET Core application, and then I want to containerize it using Docker and see how that looks like. Once we have this app containerized, we're going to push the image to a repository, and then from there we're going to take a look at Kubernetes and what Kubernetes provides, and then we're going to run this app within Kubernetes and see what kind of things that we get from the Kubernetes from the Kubernetes platform. So let's just take a look at this. What I'm going to do is I'm going to use Google Cloud for my demo, but this can be done on anywhere. There's nothing special here. So there's something called Cloud Shell in Google Cloud that basically gives you a Linux shell that you can just use to build applications. So here I'm in a Linux box, and what I'm going to do is there's already .NET command line tool installed in this Linux box. So I'm going to use that to create a really simple ASP.NET Core web application. So what I'll do is I'll just say .NET. First, I'll create a folder for my application. So I'll say hello world ASP.NET Core. That's my app. And then we'll just say .NET new -t web. So this will give me a skeleton web application that I can use to containerize later. So I have all the default files. First, what I want to do is I want to make sure that this app starts on port 8080 because I'm going to be testing this from my browser, and for that to work, I need to make sure that it runs on port 8080. So I'm just changing the main program file, and I'm adding a single line that will say use URLs, and then I'll just say HTTP port 8080. So this will make sure that my app starts on port 8080. I think you can do this through environment variables as well, but that's what I'm doing right now. So once we do that, we need to restore our dependencies. So I'll do .NET restore. This will look at the project.json file, and it will get all the dependencies that my application has from NuGet. So once that's restored, we're going to do .NET run and make sure that this application runs, because I want to make sure that the application is running before I try to containerize it. So this is downloading all the dependencies on my app from NuGet. It should take only a couple of seconds. It's done. So now we're going to do .NET run. So this will run our application on port 8080. And once it's running, there is a web preview feature here. So what that does is it basically opens a browser and finds the Linux box where this is running, and then it will connect to it from port 8080. So that's what I'm trying to do right now. So we are trying to hit that that Linux box with port 8080, and then this is the default ASP.NET Core app running in the cloud somewhere. So it works great. So the next step will be to actually containerize this application. So let's just take a look at that quickly. So here I am again in Cloud Shell. And first, what I need to do is I need to create a single DLL with all of the dependencies on my application. And to do that, I will run .NET publish-c release. So this will publish my application, which means that it will basically put everything into a single DLL with all the dependencies. I do this because I'm going to use this DLL from Docker. So Docker will call this DLL. So it's good to have this in a single file. So let's just wait for this to finish. So once this is done, what we need to do is we need to create a Docker file to tell Docker how to create our container. So we'll do that, and then we'll take a look at this Docker file because it's really important. This Docker file, it defines everything about our container. So I just want to go through that quickly and explain to you what it means once the .NET publish is done. All right, so we got our DLL. So we'll go to the release publish folder. And then now I'm going to copy. So you see that we have all the DLLs. I'm just going to copy the Docker file that I already have. And then we'll take a look at the Docker file quickly, and I'll just explain what it does. So here's the Docker file. And then here I just want to pause for a second. So if you look at this Docker file, the first line, it says from Microsoft.NET 101 runtime. So this is the base image that our application depends on. I'm using the .NET runtime image that Microsoft provides. So that's my dependency. The second line says copy.app. So it basically means copy everything in this folder to app folder in the container. Then the third line says working directory app. So that's the directory that the container will use as like the working directory. Then expose 8080 means expose port 8080 in my container. Then I'm also setting up ASP.NET Core URLs. So I just want to make sure that my app starts on port 8080 in the container. So that's what that environment variable is doing. And finally, the last line is entry point. So entry point is what happens when the container starts. So in this case, we are calling the .NET command line tool. And then I'm also specifying my DLL. So hello world ASP.NET Core.dll is the DLL that we publish. So with this single Docker file, I'm defining my dependency. I'm setting up my environment, exposing my port, and setting up my environment variables. And I'm defining what happens when the container starts. So that's the great thing about Docker, is that it lets you basically define everything you need to. So let's just go through this. So from Docker file, what you do is you build an image. So to do that, you use Docker command line tool, but we already have it installed in this Cloud Shell. So what I'm going to do is I'm going to say Docker build, and then it's a good practice to tag your images with some kind of tag. So in this case, I'm tagging it with my repository, which is Google Container Repository that I'm going to push this app to. Then I'm also tagging it with my project name, and then I'm giving it a name. So I'm going to call it hello.net, and then a version. So version 1 is the first version of my application. And dot says look into this folder to find Docker file. So now what's happening is that Docker is looking at the Docker file, and then it's going through the steps that I specified. And the first step is getting my dependency. We don't have that Microsoft image on our Linux box yet, so we are basically downloading that first. And then we'll go through the other steps once this is done. So we are downloading the image, and then we'll expose port 8080. We'll move our DLL to the container folder. Yeah, so now we are copying our DLLs, and then we are setting environment variables, and then it's successfully built. So now I have the image. So, and if we actually look at Docker, if you look at Docker images, we should see our image. So you can see that we have our image, but we also have the Microsoft image as well, because that's our dependencies already. It's there as well. To run this image, all I have to do is Docker run. -D means run in the background, and -P means port. So I'm mapping port 8080 on my Linux box to port 8080 in the container. And then I'm just pointing to my image. So this is the image that I tagged. So I'm just pointing to that. So this will take my container and run it. If I do Docker PS, I can see that my container is running. And then if I do preview on port 8080, we will see the same app again. But the difference is now this app is running within Docker, within a Docker container. So there's nothing different about the app. It's the same app. It doesn't even know that it's running in a container, but it is running within the container. So I will do Docker stop to stop the container. And then the last thing that I want to do is, since I have the image, I want to push this image to somewhere public so that I can use it later from Kubernetes. So to do that, I'm using a gcloud. It's a command line tool to talk to Google Cloud. So I'm saying gcloud docker push, and then I'm pointing to my image. So this what this will do is that it will take the image from my Linux box, and it will push it to Google Container Registry. It's a public place for your Google Cloud projects. And then later, when we create a Kubernetes cluster, we will basically pull that image and use it from the Kubernetes cluster. So I won't wait for this image to be pushed because we don't have that much time. But after a couple of minutes, this will be on Google Cloud, and we'll check it out later. All right, so let me go back to my presentation. All right, so we took our app, we containerized it using Docker. But containers by themselves, they're not enough. Because when you want to run an application in production, you need to scale up if there's demand, right? And you need to scale down if there's no demand. You need to provide redundancy. So you need to run multiple containers usually. You need to do rollouts. So if you have a new version of your container, you need to roll that out. And if there's a problem with that version, you need to roll back. You need to make sure that your containers are resilient, so you need to create health endpoints, and someone has to check those health endpoints. And you need to think about configuration, and you need to think about secrets. So there's all sorts of things that you need to do when you want to run containers in production, right? So by just taking your app and containerizing it, it's not enough. You need much more than that. So that's when Kubernetes comes into play. So Kubernetes, it's a Greek word. It means governor. And actually, just to give you a secret, everyone mispronounces Kubernetes. The right way of saying Kubernetes in Greek is Kybernetes. I know this because I'm originally from Cyprus, so we speak Greek in Cyprus. But everyone just uses Kubernetes, and that's what I also say nowadays. So Kubernetes, it's an open source project. It's written in Go. And the great thing about Kubernetes is that it supports multiple cloud and bare metal environments. So you can run it on Google Cloud, you can run it on Azure, you can run it on AWS. You can even run it in your own data center if you want to. It's a container management platform, and it came from something called Borg. So at Google, we've been running containers for a long time, and we created an internal container management system called Borg. So people who worked on Borg, they created Kubernetes basically for the open source world. So the idea of Kubernetes is that you want to manage applications, but not machines necessarily, and we'll see how that happens in Kubernetes. So at the very high level, this is what a Kubernetes cluster looks like. So you have a master. So this is basically what manages the Kubernetes cluster. And then you have nodes. This is where you actually schedule containers. And the master and the nodes, they talk to each other through something called kubelets. So that's kind of like the communication mechanism between masters and nodes. And then the master keeps track of the cluster state at CT, and it has a scheduler, and it has a controller, and it has an API server that you can talk to. But as a user, you don't really care. As a user, you just use the API or the command line or the UI to talk to the master. And if you look into the cluster in more detail, these are kind of like the big pieces within Kubernetes cluster. So first, you have your containers in some kind of registry. So this can be on Docker Hub, or it can be on Google Container Registry or somewhere else. From that registry, you create what's called a pod template. So I will talk about what pods are and what pod templates are, but you can think of them as basically a template for the container to run in Kubernetes. And then you pass this template to something called replication controller. So in Kubernetes, there's something called replication controllers, where you tell replication controller what you want, and then it makes it happen. So for example, in this case, we are specifying that we want 3 replicas. So the Kubernetes will basically look at the pod template, and it will create 3 pods, and it will schedule those pods onto one of these nodes, but you don't care as a user because it's Kubernetes' job to figure out where to schedule them. And once you have these pods running, you can attach tags on them. So in this case, we have a tag called role, and we have another tag called environment. And this way, you can use these tags to group different pods. So once your pods are running, you want to expose them to the outside world. So you create what's called a service. A service is kind of like a load balancer for pods in Kubernetes. All right. And then the outside world, so people outside your service will talk to pods through the service. So in this world, the microservice ends up being a combination of your code. So your code is basically the container. And then it's the combination of the replication controller watching your container through the pods, and also the service that exposes your pods to the outside world. So it's kind of like a marriage between your container and Kubernetes through services and replication controllers. All right. Now I have to pause here and talk about Google Container Engine a little bit, because I'm running I'm going to run my Kubernetes cluster within Google Cloud. So I want to just briefly explain what Container Engine is, so you know what I'm talking about. So as I mentioned, you can run Kubernetes. You can run Kubernetes yourself if you want, or you can run Kubernetes anywhere you want. But Google provides what's called Google Container Engine. It's basically Kubernetes as a service. So what you do in Google Container Engine is, if you want to create a Kubernetes cluster, you just use the gcloud command line tool, and you just say gcloud container clusters create, and then give your cluster a name. And this will create a Kubernetes cluster for you. So it will create a Kubernetes master, and this Kubernetes master will be managed by Google Cloud. But it also creates the worker nodes, the nodes where the containers will be scheduled. So with just one command, you get that. And then after that, you just authenticate with the cluster using gcloud container clusters get credentials. So this way, your shell is authenticated with Google Cloud. And then after that, you can just use kubectl. So kubectl is the command line tool to talk to Kubernetes. So you can use kubectl get nodes to see the nodes that you have. In this case, we have 3 nodes where we can schedule containers. You can see the pods. I'm going to talk about what pods are. And then you can resize things. So you can say gcloud container clusters resize, and then mention your cluster name, and then specify the size. So in this case, we're resizing from 3, or from default, I think default is 1 to 5. So we are making our cluster bigger, basically. So Container Engine makes all of this very easy. That's the whole point of it. So what does Google manage for you in Container Engine? It basically manages the Kubernetes master. So you don't get access to master that is managed, and it has 99.5 SLA. But it also manages the actual worker nodes where the containers are running. So you get like default logging and default monitoring and stuff like that. So that's all it does. So now we can go back to Kubernetes. The reason why I explain all of this is that I'm going to run Kubernetes in Google Cloud, so I just want to make sure that you understand what Container Engine is and what we provide there. So when you look at Kubernetes, there's a lot of terminology around it. So there's like deployments, there's pods and volumes and labels, and there's like daemon sets and stateful sets. So it can be a little bit challenging at first because when you look at it, there's so much to know. But the good news is that you don't have to know everything right up front. You can start with deployments. That's kind of like the entry point to Kubernetes. And then from there, you need to know about pods and volumes because that's how you run your containers. And labels and selectors give you a way to group different pods, and we'll talk about that. And then the other two is replica set and service. So I will talk about these in detail. But once you know all of this, then the rest is kind of optional, and you can add them as you need them. So I'll try to go through the basics of them, and then if we have time, I'll also try to talk about daemon sets and jobs. But if not, then you can read about them yourself. As I mentioned, don't let this to intimidate you initially. Just learn what you need to learn, and then from then on, you can add more complicated stuff as you need them. All right, so first, let's talk about deployments. So in Kubernetes, when you start by creating a deployment. And a deployment, basically, it's a higher level construct that you create. And then under the covers, it creates lower level things that your cluster needs. So when you create a deployment, it creates a replica set, and then that creates a pod, and then you might have a volume. Then you have a default service. So deployment basically by creating a deployment, you are basically triggering the creation of all other things under the covers. And we'll take a look at the sample shortly. So once you have a deployment, once you have a deployment, the first thing that you need to know about is pods. So pod is the smallest thing that can be scheduled in Kubernetes. So it's the smallest atom of the smallest thing that you can actually schedule in Kubernetes. Usually it's a single container because usually you just want to run a single container. But sometimes there are use cases where you want to run multiple containers together because they're tightly coupled. And sometimes you also want to save some kind of state within this container. So for that, there's also something called volume. So for example, if you look at this example, we have a container called file puller that pulls some files from some content manager, and then it saves those files to a volume. And then there's another container called web server that will serve those files to some consumers. So in this case, you want to schedule file puller, web server, and the actual storage, the volume, together. So what you do is you create a pod out of these, and then Kubernetes will schedule them all at once. So that's all there is to it with pods. And as I mentioned, the volume is your storage for containers. So they are pod scope storage, and they're basically, they can be pretty much anything. So you can have a volume that attaches to a persistent disk or Elastic Block Store or Azure file storage. So they're very flexible in terms of what you can attach to a volume. So that's pods and volumes. Once you have your pod, you can label them. So you can attach different kinds of labels. For example, in this case, you can say, I have a pod of my app, so I will label it with my app. But then you can also attach multiple labels. So in this case, I'm saying, some of these pods are prod pods, some of them are test pods, and then some of them have a front-end role, and some of them have a back-end role. So you can attach multiple labels to pods. And then once you have the labels, you can actually group things together using what's called selectors. So you can basically say, I'm going to get all my pods by specifying app equals my app. So that's my selector. But if you want to get just the front-end pods, you can say app equals my app, and then role equals front-end. Or if you want to get the backend ones, you would just say role equals backend. And selectors are really important because that's the way you group things in Kubernetes. And then when you create a service or when you create a replica set, we will use these selectors to specify which pods we care about. So you have your pods, you label them, and the next thing that you want to do is you want to you want to expose them to the outside world. So to do that, you want to create a service. A service is kind of like a load balancer for your pods. And when you create a service, you specify a selector. So in this case, we're saying I want to create a service for my pods with the label type equals FE. So all the pods that have type equals FE will be served by this service. All right. And the service will have a stable virtual IP, and the clients will talk to the service. And then from there, the service will round robin in different pods. All right, so let's take a look at these in terms of demos. So what I want to show you first is how to create a Kubernetes cluster. So in the previous step, we pushed our image to Google Container Registry. So let's just look at the registry now and make sure that our image is there, because we're going to use that later. So under the registry, there's a section called hello.net, and then there's a version 1. So that's the image that I pushed. So it's already there in the cloud, and I'm going to use that later. Now, first, we need a Kubernetes cluster. So to create a cluster, I will just use Container Engine because it's quite easy. So I'll just say gcloud container clusters create, and then give it a name. So hello.net cluster. And then after that, I want to specify the number of nodes that I want to have in my cluster. In this case, I'm just having 1 node, but I can resize that later. And then I can also specify the machine type of my nodes. So there are different sizes of machines I can use, but I'm just using a standard one that has 1 CPU and some memory. You can also specify the zone of your cluster. So in this case, I want to specify Europe West because that's where I am. So with this one command, we will get a Kubernetes master managed by Google. We will get a single worker zone that we can use to schedule containers, and everything will be running in Europe West. So I won't wait for this because we don't have that much time. But this usually takes a couple of minutes, and then after that, we have our cluster running. I'll just fast forward a little bit and then show you. As you can see, the cluster is starting up, spinning up, and then within a couple of minutes, it will be ready to use. So that's how you can get a Kubernetes cluster, and I'm sure it's pretty much the same way in other cloud providers like AWS or Azure. If you have to do this yourself, then it's more work because you have to set up networking, you have to set up the actual machines of the master and the nodes yourself. So, but if that's what you want, you can do that as well. All right, so once we have our cluster, we can actually schedule our nodes on it. So to do that, we'll use kubectl. But before we can use kubectl, we need to authenticate this shell with Google Cloud. So to authenticate, Google Cloud gives us a command that we can run. So we run that. Now this shell is authenticated with the Kubernetes cluster. And now I can use kubectl. So I'll say kubectl run, and then give my deployment a name. So I'll say this is hello.net. That's the name of my deployment. And then I'll just point to the image. So this is the image that I pushed earlier. It lives in Google Container Registry. I'm just basically pointing to that. So with this, we are creating a deployment, and I'm also making sure that the port 8080 is available in my deployment. So the deployment is created. It's very quick, as you can see. So if we do kubectl get deployment, we see that the deployment is there. And then, as I mentioned, deployment creates other things under the covers. So if I do get pods, I see that a pod is being created. It says status is container creating. If I do get pods again, now the status is running. So within a few seconds, the container is scheduled and running. If I do get replica sets, I know that there's a replica set, and we'll talk about that next. And if I do kubectl get service, we see that there's a service. It has an internal IP, but there's no external IP yet because I haven't exposed this to the outside world. All right, so this creates the deployment. Great. And now the last thing I want to show you in here is creating a service, so exposing these pods to the outside world. So let's just take a look at that. So I'm still in the shell. If I do get deployment, I know that my deployment is running. If I do get pods, I have a pod running, so everything is good. So what I'm going to do is I'm going to say kubectl expose deployment, and then pass in my deployment name, hello.net, and then type equals load balancer. So this is the type of service I want to create. So what this will do is it will create a load balancer in Google Cloud, and it will attach this to the Kubernetes cluster that we have. All right. So once this, so if you do kubectl get service, we should see a service already. There's an internal IP, but the external IP is pending because right now the Google Cloud is basically creating the load balancer, and it takes a little bit of time. And once the load balancer is ready, we should see an external IP with a real IP that we can actually hit. So I'm just going to fast forward a little bit to save time. So when I do get service now, I can see that there's an external IP. So there's a load balancer that's been created, and it's attached to the Kubernetes cluster. So if we go to that IP and hit port 880, we should see the same simple app running. But the difference is this app is not running on a Linux box somewhere. It's running within a Docker container, and the container is being managed by Kubernetes, and the Kubernetes is watching this container for me. So that's the difference from outside. Okay. All right, that's good. So let's go back to our presentation. All right, so that's Kubernetes, and I mean, up until now, if you think about it, we haven't done anything special. What we did is we took an app, we containerized it using Docker, which is great. It gives us consistency across different environments. And then we scheduled the container on Kubernetes, but there's nothing special so far when you think about it. But what's good about Kubernetes is that once your app is managed by Kubernetes, there's a lot of features that make your app more resilient, and it gives you a lot of different ways to make your app more redundant. So now in this part of the talk, I want to talk about some of these resilience and redundancy features of Kubernetes, okay? So the first thing I want to talk about is replica set. So as I mentioned, when you create a deployment, you get a replica set. And a replica set is kind of like a big brother watching your container. So you tell replica set what you want it to be true, and it makes sure that what you said is always true. For example, in this case, I'm saying, this is my replica set with this name, and this is the selector. So these are the pods that your replica set is responsible of. And this is the template, the pod template that we'll use to create pods. And then I'm saying replicas equals 4. So I'm telling replica set that I want to make sure that there are 4 containers running at all, well, not containers, 4 pods running at all times, right? And then replica sets, it will ask the API server constantly how many pods I have running. If we have 3, then it will start more. Then if we have 4, then it will just wait, right? So you will always make sure that there are 4 pods running at all times. So for example, in this case, let's say we have 2 pods, pod A and pod B, and then pod A is living on node 1, and pod B is living on node 2. If something happens to node 2 and node 2 goes down or it goes away for whatever reason, then replica set will watch this, and then it will reschedule pod B onto the other existing node 1. So it will just do that automatically for you, okay? So that's the resilience that you get from replica set. Now, replica set is also useful for scaling. So let's imagine that you have 3 pods running, and then they're being serviced by the same service. If you want to scale to 4 pods, then it's literally one command that you run in Kubernetes. With one command, replica set will create a new pod, and then it will scale to 4. So, oops, sorry, there was a lag there. So it will basically you run the command, and then replica set will create a new pod on a node that's available, and it will scale up for you. So just one command. Of course, you don't have to scale manually if you want to do auto scaling. What you can do is you can create something called heapster that looks at some metric that you care about. For example, in this case, we're looking at CPU, and then the heapster will report back to replica set. And then if a certain threshold is being met, then replica set will automatically scale your pods to something higher or lower, depending on what you want. So there's auto scaling as well. Then you can do useful things like canary deployment. So let's imagine you have a replica set that's managing 2 pods, and these pods have version 1, so they're running the version 1 of your code, and they're being serviced by this one service. And you want to introduce the new version into your environment. What you can do is you can create another replica set, but this replica set uses the version 2 of your code. And the great thing is that the service services all the pods with the label type equals BE. So this new pod will also be serviced by this one, but we can introduce it gradually in our system, and it's okay. You have 2 replica sets managing 2 sets of versions, but they're being serviced by the same load balancer basically. So this way you can have canary deployments. And then once you have your canary deployments, you want to do an update, right? Let's say that your version 2 is good and you want to update all your pods to the new version. So what you can do is basically by just changing your deployment, and I'm going to show an example of this, by changing your deployment, Kubernetes basically does a rolling update in the correct way. So what, for example, in this case, we have replica set that has 3 replicas and version 1. So when you tell Kubernetes do an update to version 2, what it does is that it creates a new replica set with the new version. Then it creates a new pod, and this pod is being serviced by the same service because it's using this label called app my app, and this service is also using that selector. So at this point, we have sort of a canary deployment. If everything is good, then Kubernetes will take one of the older ones out, and then it will add a new one to the version 2, and it will just keep going like this, taking one out, adding one to the new version. And then when everything is running on the new version, then there's no reason for the replica set anymore. It will take that replica set away, and then you have everything running on the new version, basically. So this is all done automatically for you with a single command, or when you change the deployment, it will do this for you automatically, which is nice. All right, so let me show you some of these as well in code. So first, I want to show you scaling. So here I have some pods running. What I want to do is I want to first kill this pod and see what happens when I kill it, because this is being watched by replica set. So when I do kubectl pod and then pass in the pod's ID, this will delete the pod from my cluster. And what will happen is that if you do kubectl get pods right now, you will see that there's a new pod with a new ID that's already being created, right? The reason why this happened is that replica set is watching the pod, and as soon as I delete it, it will say, oh, this is deleted. Let me just create a new one right away, and it will create a new one, and within a few seconds, you have a new pod running. So that's nice. I don't have to do that myself. So that's replica set. Now I want to show you the scaling. So let's say we have some pods running. So in this case, we have a single pod running. If I want to scale up, all I have to do is kubectl scale deployment and pass in my deployment name, hello.net. And then I will just say how many replicas I want. So I would say replicas 2. So this is scaling up. And then if we do kubectl get pods again, you'll see that it scaled right away. It's very fast. If I want to do 3, I can do that. So now I have 3 pods. 1 is pending because it's trying to find a place to schedule it, but I only have 1 node, so it cannot schedule it. If I want to scale down, I'll say replicas 1, and now we scale down right away. So scaling up and down becomes really easy with Kubernetes. And then I want to show the rolling update. So let's say I want to update my code and change something about my code, and I want to do a rolling update afterwards. So what I'm doing right now here is I'm changing a web page in the default web page and changing some message to say run on Google Cloud or something like that. So what we need to do once we change our code is we need to publish our app, get a new DLL, and then once we do that, we need to create a new image and push that image to somewhere like Google Container Registry. And then after that, we just need to change the deployment to use the new image, right? So that's the step. So change the code, create a container, push the container, and then change the deployment to use the new image. So I'm going to skip all of that because we don't have time for it. But I want to go to the place where you actually change the deployment. So now at this stage, I'm pushing my image. So this is the new image with the new code. And then now I'm back in Kubernetes. So what I'm going to do is kubectl edit deployment and pass in my deployment ID. So now I can edit my deployment. So I can tell my deployment what image to use. So once we do this, this is kind of like the configuration for my deployment. And all I need to do is, you see that there's a spec with containers, and it points to version 1 of my image. So what I'm going to do is I'm going to just change that version 1 to version 2. So that's like the next image that I created. And boom, that's it. Now Kubernetes is doing the rolling update that I showed you earlier with all the steps that I showed you automatically. And it actually already happened. So if I do a refresh on my app, you will see that the message is updated. So it happens instantly, but then it's very quick, but it happens in the right way. So it does it one by one. It doesn't do it all at once. So that's rolling updates. All right, so let's go back. And I have 10 minutes left. So I just want to really quickly, and there's more, right? I just want to really quickly go through the other things in Kubernetes and just talk about them very briefly so you know that they exist. And then in the last 5 minutes or so, I will try to answer some questions. All right, so there is more. So there's readiness probes. So how does Kubernetes know that your pod is actually healthy? Well, what you can do is you can create what's called a readiness probe. You can create an endpoint on a path on a port, and then Kubernetes will call this path and the port on some seconds that you specify. And then when your pod says, I'm not healthy, then it will basically tear it down and create a new pod somewhere else. So that's nice. Sometimes your pod is actually healthy, but it's not ready to serve traffic yet because maybe your pod needs to go to database and get some state before it can serve traffic. So for those kind of use cases, there's something called liveness probes. So in liveness probes, it's the same way you create an endpoint and a port, and then Kubernetes will ping that endpoint and port. And when it says OK, then it will start serving traffic. Otherwise, it won't serve traffic, but it won't also kill your pod either. It will just keep your pod there until it's ready to serve traffic. There's a dashboard that comes with Kubernetes, so you can see your deployments, your replica sets, your daemon set, your stateful sets, all sorts of things. I actually have a demo of this, but I don't have time to show it to you. But you can try it out yourself. It's very easy to run, and by default, you get all this stuff. It's mostly view only, so you can see a lot of things, but you can also change a few small things here and there, and it's getting better and better with new versions of Kubernetes, but it's mostly for viewing things rather than managing them. Then there's something called daemon sets. So the pods, they can live on any node. There's no guarantee that some pod will live on every single node. But there are some use cases where you actually want the pod to live on every single node. So for example, let's say you have a pod that does some audit logging or something like that. You want to make sure that everything on a node gets logged or something like that. For those kind of use cases, you can create a daemon set, and that way it's guaranteed that your pod is running on every single node. And then there's something called jobs. So pods, they usually run forever until you kill them. But then even if you kill them, replica set will see that and it will create a new pod, right? But there's some certain use cases where you actually want pods to do some job and then finish and then die because you don't want to keep paying for them. So for those kind of jobs, there's something called jobs. It's basically for batch processing. Let's say you have some kind of processing to do. You create these pods, you do your job, and then once you're done, the pods will go away, and then everything goes back to zero, right? And then the next thing I want to talk about is config maps. So configuration of an app is really important. We don't think about it too much because we think about our code usually, but configuration is really important, and Kubernetes provides something called config map. It's a central place where you can define your configuration, and when your pod starts, it will basically attach a volume to your pod with the configuration, right? So this way, it's a central place for all your configuration, but every pod, when it starts, it gets a volume with the configuration, and that's nice. And the next thing is secrets. So sometimes you want to store your secrets somewhere, so you can do it the same way, like config maps. You could define it in a central place called secrets. And then when the node starts, it will get a volume with the secret, which is nice. All right, so that's all I have. Thanks very much. This is my Twitter. So I'm going to probably publish the slides there. And then it's my email as well. So if you have any questions, feel free to ping me. And I just want to see in the last 5 minutes if you had any questions on the chat.
All right, thank you so much, Mete. Can you turn on your camera? Because we have a few questions that we'd like to get to.
Okay, let me do that 1 sec.
Right. So
Yep.
This is a pretty long question. It's a two-parter.
Okay.
So the first one is from Taylor. Does JKE support Windows containers?
Not yet.
Not yet. OK. So
No.
that actually stops there. So let's go to the next question. The next question is, what components are responsible for synchronicity, the equivalent to task queues?
So, I mean, in Kubernetes, there's no such thing as task queues or anything like that. So it's something that you need to do that yourself. So if you're running in the cloud, you would basically use some kind of a task queue that the cloud provider provides. But in Kubernetes, there's no such thing as a task queue or anything like that.
Okay, perfect. A question from Andre. Will this work the same way in Linux?
Well, everything I showed is on Linux, actually. Yeah, so it works.
It works.
Yeah.
All right, and finally, our last question from John Smith. How easy is it for me to import or upload my own images into Kubernetes instances for running the platform?
So, I mean, as long as you create your own, I assume he means container images.
Yes.
And so as long as you have a container image, and as long as this image lives somewhere public, like a Docker Hub or Google Container Registry or some kind of registry that's public, then you can use it from Kubernetes. That's the only requirement. So it's a container that's in a public place. You can pull it from there and just use it from Kubernetes.
All right. And you mentioned earlier that the slides will be available for people to use, correct?
Yes, I usually publish my slides after my talk on Twitter. So if you want to get them, I'll just find me on Twitter, and it should be there.
Okay, perfect. Thank you so much for joining us. We really enjoyed your talk, Mete. And we will be back in a couple of minutes.